All right, this is Math Counts 2013 chapter competition, and we're going to look at 13 through, I don't know, how about 18? All right, hopefully we can go through this one quickly. The perimeter of the rectangle is 22 centimeters, and its area is 24 centimeters. What is the smallest of the two integer dimensions of the rectangle? Okay, so we know that length plus width is going to be equal to half the perimeter, so that has to equal 11. And we know the area, this length times width, is going to equal 24. Well, this is kind of like a factoring problem, isn't it? What two numbers multiplied together equals 24, but add together to get 11? 6 and 4? No. 8 and 3? Yeah, 8 and 3. 8 times 3 is 24. 8 plus 3 is 11. So we know that the side lengths are 8 and 3. So what is the smallest of the two? It is 3. 14. On Tuesdays, Mr. whatever, I want it to be George Costanza, but I know it's not George Costanza. Classic. Walks from his home, located at one end of Main Street, to the grocery store at the other end. And on his way down Main Street, he passes the post office and the police station. All right, in that order. His home is 7.5 blocks to the police station. And the post office is 6 blocks from the grocery store. All right, and we need one more piece of information. Here we go. And 3.5 blocks from the police station. Oh, well, we just need to find this distance here. Well, from post office to grocery store is 3.5, or 6, and 3.5 of it is taken up here. This must be 2.5. 2.5 plus 7.5 is 10 blocks. Farmer Hank, reminds me of our former student. Farmer Hank has fewer than 100 pigs on his farm. If he groups his pigs 5 to a pen, so groupings, there will always be 3 pigs left over. So I'm going to call that remainder. So if he groups them in 5, he'll have 3 left over. All right. However, if he has 7 pigs to a pen, he will have, there'll be 7 to a pen, there'll always be 1 pig left over. And if he has 3 pigs to a pen, no leftovers. All right, so we're looking for a multiple of 3. That is 1 less than a multiple of 7 and 3 less than a multiple of 5. Well, for the 5, that means if it's 3 less, that means the number has to end in an 8, or it could end in a 3. And it has to be divisible by 3. I'm going to go through some multiples of 7. And let's start at multiples of 7 that are close to 100. Oh, what, you don't know? Okay, let's start with let's start bigger than 50, shall we? All right, so 49, obviously. So 56. Now 56. Well, 56 is divisible by 7. So I'm going to add 1 to 56. So that would get 57. Does 57 end in a 3 or a 8? No, so this does not work. Well, the next multiple of 7 is 63. Plus 1 is 64. Again, not a 3 or 8. So then 70 plus 1, 71, is not a 3 or 8. I could go 77 plus 1 is 78. Oh, now this does end in an 8. Well, is 78 divisible by 3? The answer is yes. Okay, so that works, but we need to check the others, because there might be one bigger. So 84, add 1 is 85. Nope. 84 plus 7 is 91, plus 1 is 92. Nope. So add 7, 98, plus 1, no, is a 9 at the units digit. It does not work. So 78 is the final answer. 3 people can paint 5 rooms in 2 days. Working at this rate, how many days will it take 6 people to paint 15 rooms? All right, so 5 rooms. Actually, let's start off a little bit different. So we have people, we have rooms, and we have days. People, we have 3 people, 5 rooms, 2 days. And I need to convert that to 6 people, 15 rooms, and I need to know this number of days. All right. So the best way to do this is we really, honestly and truly would like to figure out, well, we could do it to figure out how much one person does and then scale it up by 6. I mean, that would definitely work. Another way we could do this is, yeah, that's pretty much it. All right. So this means that one person could do 5/3 of a room, and that would take them 2/3 of a day, I think. Hold on, let me double check this. All right, so we're on the right track. So multiply by 6. So we get 6 people can do, multiply this by 6, 10 rooms, and it would take 2 days. All right. And so really just multiply this by 2 is really the fastest way to do it. So that would get me 6, 10, and hold on a second. And the number of days hasn't changed yet, so it's still 2 days. Okay. Because I just doubled the number of people, means the double number of output, and the time hasn't changed. Well, if 6 people can do 10 rooms in 2 days, that would mean that 6 people could do 5 rooms in 1 day, just half of it, right? Oh, well, so it would take another day to do the extra 5 rooms. 1 day plus 2 days is 3 days. All right. Last 2. At a school's carnival, one game features a dartboard. Why? I don't know. With 5 smaller squares shaded. The length of the side length of the square dartboard is 4 times the length of any side of the. Okay, so it's 4 by 1. Because it doesn't matter if we use a scale factor of 2, 3, whatever, the ratio will still be fine. What is the probability that a player will win a prize if they hit a shaded section? Well, if that just means this is divided into fourths, right? Well, if I move this one down here, move this one down here, move this one down here, I've shaded 5 of the total 16 possible squares, because I can continue this, right? And I did a bad job, it would have gone here, but whatever, you get the idea. So we get 5 out of 16. All right. Linear relationships rock. So a line passes through -2, 8, and 5, -13. When the equation of the line is written in the form y equals mx plus b, what is the product of m and b? All right, so we need to find the slope, we need to find the y-intercept. Slope is the difference in the y values, or in other words, y2 minus y1 over x2 minus x1. So y2, y1, so we get -13 minus 8. Oh, that's -21. Yikes. We have 5 minus -2. Oh, phew. That's 7. So we get -3 as the m value. Okay, that's not too bad. So we can keep that in our back pockets. And now we need to find the y-intercept. Well, if I'm at -2, 8, and I go down 3 for every 1, if I'm here at -2, -1, and 0, that means I'm going to go down 3 over 1, down 3 over 1. So that means I went down a total of negative 6. 8 minus 6 is 2. So the y-intercept is at 0, 2. So 2 times 3 is negative 6.